Hi, and welcome to Power Factor Correction Training. So a number of our strata apartment buildings have old lifts, perhaps two old lifts, maybe an air conditioning system. And a number of these apartment buildings often have a poor power factor, but power factor is not very well understood. So we're going to use a cappuccino as an analogy to explain what's going on. Now, buildings with better power factor will effectively have less froth, and that means your power bills will be lower. So a power factor of 1 is the best that you can get. Power factors of 0.9 or 0.8 are getting decreasingly worse than a power factor of 1. And some buildings might have a power factor as low as 0.5. So if we look at a typical bill, you can see the network charges on this EA 305 tariff. There's an item called peak capacity. This is the line that's driven up by poor power factor. So first of all, only buildings that consume more than 160 megawatt hours of electricity per year will get bills that actually show peak capacity. And this peak capacity is based on the peak apparent power. That's the power from the cappuccino, including the froth. If we can improve our power factor, get it closer to 1, we can decrease the froth on the cappuccino and then decrease our peak capacity charges. If we look at a typical bill from an energy retailer such as Energy Australia, you'll see some additional information such as actual demand, which is 34.32 kilowatts, and actual demand in kilovolt amperes being 45.95. So if we apply the formula, power factor equals peak demand in kilowatts divided by peak demand in kVA, then we'll find that this building has a power factor of 0.75. So it can be improved to get it closer to 1. So how do we actually work out how much you could save by improving the power factor up to 1.0 in this building? This is a bill that is for a billing period of 31 days. So we can see the actual peak capacity charge is 35.7417 cents per kVA per day times the actual demand, which is 46 kVA a day, times 31 days in the billing period, giving us a peak capacity charge of $509.68. Now, if we were to move this building up to power factor of 1, then we would move to an apparent power of 34.32 kVA. And the new peak capacity charge would be calculated to be $380.26 per month. So if we multiply the difference between those two amounts by 12 months of the year, we'll save $1,553. So you can improve your power factor by installing a power factor correction unit. Here's a case study of a power factor device being put into an apartment block of 143 apartments in Surrey Hills in Sydney. And this was a 200 kVAR power factor correction unit. So power factor correction units themselves come from 25 kVAR up to, say, 200 kVAR. And the more kVARs that there are, the more expensive the power factor correction unit. So this was quite an expensive one, being a 200 kVAR unit, but it still gave payback in 1.2 years. So who are some power factor correction suppliers? AGL's ElectroServe unit, Edge Electrons is quite an innovative power factor correction supplier, and Ducati Energia are just a few, and there are many others that you can find. So I hope this helped you with understanding power factor correction in our residential apartment buildings. Thank you.